Is the second part of the projectile motion. In previous part we learnt about what is the path of the projectile and we derived one equation for that. I'm just reviewing the topic back. Actually, projectile motion is the best example for motion in a plane. In that we have the two physical quantities. The velocity vector is resolved into two components along the x-axis and y-axis. The two velocities are independent, but a common factor is along with them. That means the time period. At the same time, they exhibit both kinds of displacements, one along the x-axis and one along the y-axis. Okay, students, let's analyze the projectile motion further. Later, we'll learn about the other factors which are involved in, like the time period, horizontal range, and as well as the maximum height. Let's say it's a two-dimensional plane and we analyzing the motion. You know that it is the path of the projectile. How did we get that? I said projectile is nothing but any body which is thrown making an angle of theta with the horizontal. Making an angle of theta with the horizontal. Throwing means what? We are imparting some velocity to that. Let's say it is the velocity. We call it as the u. Then after we had to resolve the velocity into components along the x-axis and as well as the y-axis. You are aware of this. Horizontal component we call it as ux and it is equal to u cos theta, and it is a vertical component. We call it as uy and it is equal to u sin theta. Okay, and you have to remember here, when you take any projectile motion, the horizontal component of velocity always remains constant. That means what? It is not experiencing any kind of acceleration. But the vertical component of velocity get affected by acceleration due to gravity. That's why the position of the particle is changing with respect to time. The position of the particle changing with respect to time. Now we are taking a point here. Here we are analyzing the motion of the particle. What velocity it has. Okay, and similarly, what are the components of velocities and how much it reaches this height, and what would be the velocity after some interval of the time. Let's locate a point. It is a point. I am dropping the normals. Actually, what I am doing, I am trying to draw a position vector. This point, okay, P, has the components along the x-axis and y-axis has, the coordinates x comma y. Okay, students, on reaching this, it is the direction of the velocity. It is its horizontal component and it is the vertical component, and it is the angle made by the projectile. It is not similar to this. The two are different. Let's say it is alpha. Obviously it is ux and we call it as the vx. We located this point as P. Okay, students, are you following? And as usually it is the range. Okay, here we are analyzing the particle here. Okay, first we will find, or we will write the components. If say at that point the velocity is v bar, we can write it as vx I cap plus vy j cap. Okay, I said throughout the journey the horizontal component of the velocity remains constant. It is Vx. Already I wrote it as Vx. Here Vx is equal to Ux, I said, or we know that is what Ux, U cos theta, I cap. Similarly, we have to find the Vy, j cap, that is Vy, and we are using the equations of kinematics now. Okay, if the velocity is changing, we have a relation between the change in velocities as V is equal to U plus At. Here we are working against the gravity. G is down and acceleration, it is direction. Okay, we are taking it as negative. Then Vy can be written as Uy minus Gt. Okay, students. Then Vy can be written as Uy, we have U sine theta minus Gt, j cap. Okay, together we can write the equation velocity V bar is equal to, I told Vx I cap, that is U cos theta I cap plus, okay students, it is U sine theta minus Gt into j cap. It is the velocity of the projectile at that point. Velocity of the projectile at that point. Then after we have to find out the magnitude of the velocity. Magnitude of the velocity is what? V bar is equal to under root of Vx squared plus Vy squared. That is V is equal to under root of U cos theta squared plus U sine theta minus Gt whole square. It's the velocity of the projectile at a given time. The velocity of the projectile at a given time can be had as V is equal to under root of U cos theta whole square plus U sine theta minus Gt. We are analyzing. The second thing, what you have to find, okay, here we got the velocity and the angle made by projectile, angle made by projectile after t seconds. Okay, as you know that it is the vertical component and it is the horizontal, it is the alpha. Okay, from the diagram we can write tan alpha is equal to Vy by Vx. Okay students, here Vy already we got, it is Uy minus Gt, okay, by Ux, or simply we can write tan alpha is equal to U sine theta minus Gt by U cos theta, or alpha is equal to tan inverse U sine theta minus Gt by U cos theta. Here in this way we can find the velocity. I hope you are understanding. In the same way we have to find out the height. Let's say this displacement is y. We have to use the simple relation. What it would be? See, how can we get? We know that S is equal to ut plus half gt squared. Yes, we are saying it as the h. Here this height we are taking u u sine theta, okay, into t minus half g t square. And substituting these values, we will get the height of the projectile after a given interval of the time, and similarly the angle made by it after a interval of t, and the velocity of the projectile at a given interval of the time. Okay students, in next chapter, that means what? In next edition of the video, we will do the problems which are related to the projectile motion. Okay students. Okay, then after we will know about the factors which are affecting the projectile motion. That means the physical quantities which are related to the projectile motion. Okay students, here mainly we have to talk about the physical quantities when we consider the projectile motion. One is the time period. Second is horizontal range. Third is maximum height. Okay students, these three are very important thing. This time period is shown with the letter capital T, range is R, and its height. Actually we are in two-dimensional motion, isn't it? Here it is the projectile motion we are talking about. The two, it's the second part of the motion, projectile motion. That's why I'm writing it as 2. That means who want to learn more about it can watch the video. Then it is a two-dimensional plane. We are finding the three different factors which are involved in. One is the time period, second is, okay students, second is the horizontal range, and third one is the maximum height. Let's start. It is the projected velocity, and you know that it is u cos theta, horizontal component, and it is u sine theta. Okay, first we have to find out what is the time period is. This one we are targeting. What is the time period? It is the time for which the projectile remains in air, is known as time of flight. That means the time taken by the projectile to travel along this path, this trajectory. If you watch it carefully, it starts from here and end up here. Means what? The vertical displacement of the particle is equal to 0. The vertical displacement of the particle is equal to 0. Okay? For vertical displacement, we have the equation, isn't it? We are targeting about time period. Now, what is time period? It is the time for which the projectile remains in air. For vertical displacement, we have a relation. Y is equal to, that means what? Yes, I am writing it as S only. S is equal to ut plus half at square. I told you, after reaching this position, it started from here. It is a ground to ground position. Vertical displacement is equal to 0. Then we are writing S as Y. U as vertical component of velocity here. It is u sine theta. Okay, is taken as negative. I am saying vertical. That's why acceleration should be taken in opposite direction. And what we have, see this? Y is equal to u sine theta into t minus half g into t square. I told y is equal to 0, vertical displacement is 0. then it can be replaced as 0. And we had u sine theta t is equal to, what to get, half gt squared. Square and t get cancelled, and we had t is equal to 2u sine theta by g. It is the equation for time period. Time period can be had as t is equal to 2u sine theta by g. Here I am freezing it. That is t is equal to 2u sine theta by g. We got the value of the t. What I said, time period is a time taken by the projectile. That means to be remain in air. The time taken, the time for which the projectile remains in air is the time of flight. Okay, if you watch it carefully, you will find if you take theta is equal to 90 degree, what you get? It is t is equal to 2u by g. The similar equation what you have learnt in what is that, vertically projected bodies, and as well as the what is that, freely falling bodies. There is sum of the time of ascent plus time of descent. Time of ascent up to here, later it is time of descent. Okay, let's go with horizontal range. The next part what you have to learn is the horizontal range. Okay students, what is the horizontal range you have to understand? Okay, it is the horizontal distance covered by the projectile in time of flight. It is the horizontal distance covered by the projectile in time of flight. This one, displacement along the x-axis. It is the x-axis, isn't it? It's the y. Okay, horizontal distance covered by the projectile in time of flight. But we have to talk a lot about this. If it is the vertically projected body, vertically, that means what? Vertical component get affected by acceleration due to gravity. But from the beginning we are saying that acceleration along the x-axis remains constant, since it is not experiencing any effect of the gravity. Okay, then we can write for what? Uniform motion. We have a relation, velocity is equal to displacement upon time, or displacement can be written as velocity multiplied with the time. Here, what is the velocity? Horizontal component of velocity. V has to be taken as Vx, and you know that it is u cos theta, and S is the displacement. We are calling it as r. Okay, then we have to substitute the values in, and t, time of flight, already we registered value here. T is equal to 2u sine theta by g. We are substituting these parameters in this relation. What you get? R is equal to u cos theta multiplied with the t, but t is equal to 2u sine theta. It is u cos theta into 2u sine theta by g. It can be written as u square into 2 sine theta cos theta by g. But here 2 sine theta cos theta is equal to sine 2 theta. It is a mathematical relation. Then you can write range is equal to u square sine 2 theta by g. Okay students, the equation is R is equal to u square sine 2 theta by g. We can get an application from this for maximum range. To get the range which is maximum, theta might be equal to 45 degree. If you substitute it, you will get the maximum range is equal to u square by g. Is the very important relation. Okay, in this way you can find out the horizontal range. Horizontal range is shown with the letter R. Okay, what is the horizontal range? It is the horizontal displacement of the projectile in time of flight. That too, horizontal component of velocity doesn't get affected by the acceleration. That means what? It is the uniform motion. That's why we use the basic equation. Velocity is equal to displacement upon time here. And finally we got R is equal to U square sine 2 theta by G. Or in other words, if theta is 45, the range might be maximum, or max is equal to U square by G. Okay, students? Then after, we are going to do one more. Okay, horizontal range is completed, and finally we have to think about maximum height. The 2 is over. Now we are going to do this. Maximum height. Okay. It is the maximum vertical displacement of the projectile. Okay, it is the maximum vertical displacement of the projectile. Okay, here it can be shown like this. If you watch it carefully, it is the maximum displacement. It is h, but it is y component. Okay, you know that v square minus u square is equal to 2s. Here, say this, the projectile is moving on. Throughout the journey, ux remains constant and uy at the maximum height vy is equal to 0. Okay, students, we started with the velocity uy here, and after reaching this point, vy becomes 0. Okay, let's take vy is equal to 0. Okay, u means what? It is u is equal to uy is equal to u sine theta, and a is minus g, and s is equal to h. Just put the values there. What you get? 0 minus u sine theta whole square is equal to minus 2g h. In other words, u square sine square theta, we eliminated minus, is equal to 2gh, and h is equal to u square sine square theta by 2g. Is the equation for the maximum height. What's the maximum height? It is the maximum vertical displacement of the projectile before its final velocity. What is the maximum height? It is the maximum vertical displacement of the projectile before its vertical component of velocity. Okay, becomes 0. Here only it becomes 0. And we had. Then after we will find when will be the height is maximum. Obviously, theta is 90 degree. That is, h max is equal to u square by 2g. These are the three desired relations, okay, in projectile motion. Today we analyzed, okay, the projectile motion, and also we derived the expressions for time period, range, and as well as the maximum height. Okay, students, thanks for watching my video. If you like, don't forget to subscribe my channel.